All right, so today we're going to look at dividing. For whatever reason, like students always remember to multiply first when they get them, but they never want to divide first, and I don't understand why that is. But you always want to make sure you divide or simplify fractions first, and then try to do any other simplifying after that. All right, so when we have a big old radical, like the big tall one over an entire fraction, we can split that. And I would recommend that you do that every single time, right? Go ahead and split that so there's a radical on top and a radical on bottom. Okay, because what happens a lot of times, if you leave the big tall radical, a lot of times we just leave it like that and we don't even try to simplify. Or sometimes you take the square root of one of them and then not both, and then it messes up the whole problem. So I like to see it split as your first thing that you want to do with that. It's considered simplified when there's no fractions inside that radical. Like we cannot leave a fraction underneath there. So that's when we split it. By splitting it, then I can kind of simplify part or all of it. So this would split to radical 3 over radical 4, right? Just splitting that apart. Radical 3 I can't do anything with, but the square root of 4 is just 2. So that allowed me to simplify part of it, but then the radical still stayed on that top. All right, so number 1, we'll start real basic and kind of get harder as we go here. So radical 16 over 49. So first thing we want to do is split it. So it's a radical 16 and a radical 49. That way we don't forget that that actually goes to both top and bottom. Square root of 16, that's just 4, and the square root of 49 is just 7. And in 4/7 I can't simplify any further, so I am done. Now, one thing I see students do quite often is they'll take the square root of 16 and they write down 4, and then they stick the radical back over top of it, and then they turn it into a 2. When you guys go to the bathroom, what do you do with your toilet paper? What do you do when you're done with it? Do you keep it? Do you sit it to the side and use it again later? That's disgusting, right? Why would anyone think? That's what it's like when you're doing it on the radical. Stupid ways to remember things, guys. That's how you remember it, right? So if I look at you later and be like, you reused your toilet paper, that's what I'm referring to. That's disgusting. We don't do that. No one's going to be your friend, okay? Don't do that. So if you use the radical on the 16 to make it a 4, don't put it again on the 4 and use it again to make it a 2. That's gross. Don't do that. Okay, so once you've used it once, it's gone. Flush it away. Don't reuse that. All right, so number 2. We'll split it apart. We have radical 2 over radical 81. Square root of 2. Can I do a factor tree, find some pairs, do anything with that? No, it's going to stay just radical 2. And then the square root of 81 is 9. Should I put a radical on it and turn it into a 3? Why not? Because that's disgusting, right? Don't reuse it. Okay, I used it on the 81 to make it a 9. I'm done with it. And then number 3, we will go ahead and split that apart first. So radical 8 over radical 25. Square root of 8. Can I do anything with that? Yes, I can. I can do factor tree, right? So I can do 2 and 4. And that's going to become 2 and 2. So we'd have a pair of 2's to come out, and then a leftover 2, leftovers in the fridge. And then the bottom square root of 25 is just 5. Okay, so if they're nice and pretty, obviously we like those the best or the easiest, but if not, we can do factor trees if we can, look for those pairs. Questions so far? Those are the easy ones. Because we know in math, sometimes there's those weird rules that kind of exist, right? And here's one of those. It is considered not simplified if you have a radical in the bottom. Radicals can sit up top, totally fine. Does not bother anyone in the slightest. Radical on the bottom, not simplified. So we have to do what's called rationalize the denominator. We are rationalizing. So if you hear me say that term rationalize, it just means get rid of the radical that's on the bottom. All right, so after you have simplified every single thing you possibly can, and not until then you will, if you have a radical in the bottom, you will go ahead and rationalize. So whatever that radical is in the bottom, if you multiply it by what itself, radical 3 times radical 3 makes radical 9, and then the square root of 9 is 3. It's like you made a pair of 3's, right, from your factor trees. What happens to those pairs? One of them comes out. So that's what we've done. We've created a pair so that I can pull it out. But if we do that to the bottom, we've got to be fair and multiply that by the top. 2 times radical 3 is just 2 radical 3. It's going to stay there. Right? So number 4. Now I said you don't do that until you've simplified everything possible, right? So before you even think about rationalizing, you want to go through your kind of steps in your head of, can I simplify anything? So can you simplify the fraction? If you write down some steps here, step 1 would be to simplify your fraction. For whatever reason, people never want to do that first. And you can still do the problems, but your numbers get huge. And then you have a lot of simplifying to do. All right, so simplify fractions first. Then you will try to use your radicals. So use radicals. If it helps you, you could write factor trees. Then, after we've kind of done everything we possibly can, then we will rationalize denominator. And then last, simplify anything that we possibly can. Sometimes that creates other things that allows us to then simplify further. And I'll show you one in a little while that you can do it without simplifying first, but how much harder it makes those problems. All right, so number 4, simplify fraction. 7 over radical 5 doesn't simplify. Use my radical. Can I do a factor tree on radical 5? No, it doesn't help me at all. Okay, so since I kind of exhausted step 1 and step 2, I can then try to rationalize the denominator because I can't leave a radical on the bottom. So we multiply top and bottom by radical 5. What's 7 times radical 5? Good, 7 radical 5. One's in a radical, one's not, so they don't actually multiply together. And then what's radical 5 times radical 5? That would give you radical 25, which is just 5. And then can I simplify? Can I simplify these 5s together? Do they cancel out? I see a head shake of no. No, they don't. Okay, because that one's under radical, this one's not. They're not the same. Right, the square root of 5, that stands for an actual number, right? It's like 2 point something. So it's not the same. Martin, you with me back there? All right, number 5. So simplify fraction. Can I simplify the 6 and the radical 6 together? No, one's a radical, one's not. Okay, use the radical. If I do a factor tree on the radical 6, do I get any pairs? No, I just get 2 times 3. All right, so then I'm at rationalizing. So I multiply top and bottom by radical 6. 6 times radical 6. 6 radical 6. Radical 6 times radical 6. All right, that's going to give you radical 36, which is just 6. So the radical in the bottom's gone. Can I simplify that fraction? Yes. This 6 out in front and the 6 on the bottom, they're not under a radical. I can go ahead and simplify those. So my final answer then is just radical 6. Okay, number 6. Radical 10 over radical 3. Can I simplify that fraction? Does 10 over 3 simplify? They're both under radicals, right? So I can think of it that way. But it doesn't. Can I use the radical? Factor tree on either of those? Find me any pairs. No, 10 is just a 2 and a 5. All right, so then we will rationalize. So top and bottom by radical 3. Right, whatever that bottom one is. Radical 10 times radical 3. Good, it's radical 30. Radical 3 times radical 3. Good. It's radical 9, which is just 3. And then simplify. If I do a factor tree on 30, does it get me anywhere? 3 and 10, and then 2 and 5. So there's no pairs there. Can I simplify the 30 and the 3 together? No. One's a radical, one's not. So that is as far as that one goes. So are you allowed to leave a radical on the bottom? No. Anytime you see that, we know that we've got to get rid of it. right, so number 7, 5 radical 2 over radical 15. Okay, can I simplify my fraction? Right, there's only one outside number of 5, so that's not going to simplify. 2 over 15 doesn't simplify. All right, can I use the radical to find some pairs? Any pairs on 15? Nah, it's just 3 and 5. All right, so then I will go ahead and rationalize. So we multiply top and bottom by radical 15. So on the top, we'd end up with 5, and then multiplying our radicals, 2 and 15 make 30. Radical 15 times radical 15, it's just 15. I think it's what, 225, I think, if you multiply them. But it makes it just 15. Okay, and then try to simplify. Anything simplify there? Yeah, 5 and 15, I can divide them both by 5. 5 divided by 5 is just 1. 15 divided by 5 is 3. So we get radical 30 over 3. We know from the last problem, that's as far as that one goes. All right, number 8. What should you do with that first? Break it apart. Good. Yeah, we got one big tall radical. Don't leave it like that. First step is always to kind of split those. All right, so can I simplify 5 over 14? No. Okay, can I use the radicals? If I do factor trees, do I find any pairs? No. All right, so then I need to get rid of that bottom number, right? So multiply top and bottom by radical 14. Radical 5 times radical 14. Is that 70? Okay, and then radical 14 times radical 14 is 14. And then simplifying, can I simplify the radical 70? If I do a factor tree there, do I find any pairs? Be 7 and 10, 2 and 5, so there's no pairs there. So we are done. All right. Number 9 is usually where students start to fall apart. Tell you what, let me give you a minute. Try number 9 on your own. All right, if you followed what I had asked you to do, was to do what first? Simplify and use those radicals. Should rationalizing be like one of the first things you do? No, and a lot of you it was. Okay, you can still get there, but it makes the problem a lot harder. So radical 27 over radical 8. So my suggestion was to actually simplify, which it doesn't as a fraction, but I can do factor trees. So 3 and 9. 3 and 3. So we're going to get a pair of 3's that come out and a leftover 3. On the bottom, that's 2 and 4, 2 and 2. So a pair of 2's and a leftover 2. That's what I wanted to see that you did first. And not all of you did. Okay, from there, the only problem I have is I still have a radical on the bottom. So to get rid of that radical on the bottom, we have to multiply top and bottom by radical 2. This 2 is not a problem out here, so I'm not worried about that one. Just multiplying top and bottom by that radical. So on the top, I get 3. Radical 3 times radical 2 is radical 6. On the bottom, radical 2 times radical 2 is radical 4, which is 2, times the 2 that's already there is 4. And we are done. That is not the route a lot of you took. Let's talk about the other route. Okay. The other way people went with this. It's radical 27 over radical 8. Some of you went, oh, look, there's a radical in the bottom. I should probably do something about that, right? And you multiplied radical 8 on top and bottom. Nothing wrong with it. But what's radical 27 times radical 8? What is it? 216. And that becomes just 8 on the bottom. Okay. But then you have to simplify, right? You got to simplify all your answers at the very end. So you have to do a factor tree here. So that's 2 and 108, 2 and 54, 2 and 27, 3 and 9, 3 and 3. So my factor tree got real big. Looking for pairs, pair of 3s, pair of 2s, and a I got a leftover 2 and a leftover 3. So that gives me 6 radical 6. And I still had an 8 on the bottom. And then 6 over 8, divide them both by 2. Makes that 3 over 4 and radical 6. Got the same answer. Which one was less work? The first one was less work. Because what happens is sometimes those numbers get huge. Like what if you had like a 53 and a, I don't know, 72? Then you had to multiply top and bottom by radical 72. Like your numbers could get huge. And then your factor trees get huge. And then what happens when I think I'm done? I still have to simplify my final answer. So if I simplify early, my numbers are smaller, and I don't have to simplify at the end. Okay, it's a lot easier that way. All right, so number 10. Radical negative 63 over 52. Oh, look, there's big numbers again. All right, right away, I notice I have a negative under my radical, which is what? That's going to make an I, right? So when I go ahead and split this, I'm going to go ahead and pull the I out. So I radical 63 over radical 52. Okay, let's start there, right? Just pull that I out so I don't lose track of it. All right, so 63. Can I do a factor tree there? Yes. That's going to be, what, 3 and 21 and 3 and 7. So I end up with a pair of 3s. And I have an I. And I got a leftover 7. What about 52? 52 is what? 2 and 26, 2 and 13. So I got a pair of 2s and a leftover 13. All right, and then from there, I cannot leave a radical on the bottom. So we multiply top and bottom by radical 13. So on the top, I have 3i. 7 times 13. Good. So radical 91. And on the bottom, radical 13 and radical 13 give me, that's going to make just 13, right? Radical 169, which is 13. So 13 times the 2 that's sitting there is 26. Simplifying at the very end just to make sure we're good. 3 over 26. That's not going to simplify. Radical 91, that came from 7 and 13, which are both prime numbers. So I know that that's not going to have any pairs either. So I'm done. Think if you had not simplified first. You would have multiplied top and bottom by 52. 52 times 63. Numbers are getting big, okay? They're a lot less manageable. You can totally do it that way, but it's a lot more simplifying. It's a lot harder if you ask me. All right, so number 11. Does those double negatives just make a positive? No. All right, a radical is kind of like a jail cell. It holds whatever is inside of there. So like that negative on the outside doesn't affect that negative on the inside. What's the negative on the inside become? That's an I. Good. So this is actually, right, that's positive, and I actually comes out. What's the square root of 36? 6. So that's going to give me negative 6i on top, right, because that I out there was negative now. 48. It's not perfect, but you can do a factor tree. So 2 and 24, 2 and 12, 2 and 6. 2 and 3. Pair of 2s is 4. And a leftover 3. Am I done? Oh. All right, now what? Good. Multiply top and bottom by radical 3. So it gives us negative 6i radical 3. What do we end up with on the bottom? What? That is 12. Good. Because radical 3 times radical 3 is radical 9, which is 3, times the 4 is 12. Done? And then I got to keep going. Yeah. All right, I got to simplify my fraction. 6 over 12 becomes... It's negative half, right? I divide them both by 6. So negative I radical 3 over 2. Right? You were just dividing everything by 6. You want to multiply top and bottom by radical 48 instead to start that problem? I have students who do it all the time. And they wonder why they struggle and why homework takes them 6 years to get done. It's because they do it the hard way. All right, last one on your own. All right, first thing most of you did was saw the negatives in there and pulled those out as i's. Okay, which is totally fine. But if I have an I on top and an I on the bottom, what happens with those? They cancel out. There actually aren't any i's. What if I didn't even pull out the I? Ooh, if I didn't even pull out the I at all? Negative 40 over negative 6? Two negatives make a positive, so there really is no I. Okay, so either way, if you pull out the I, it's totally fine. Just recognize I on top, I on bottom, they're going to cancel out. Some of you started from here by rationalizing. Okay, simplify. 40 over 60 simplifies to what? I can divide both of those by 2. So that would give me radical 20 over radical 3. Make your numbers a little smaller so I can simplify those. Okay, I can do a factor tree on the top. 2 and 10, 2 and 5. So I get a pair of 2's and a single left over 5. Still have a radical 3 on the bottom. And then from here, I'll just multiply top and bottom by radical 3. So we get 2 radical 15 over 3. I think some of you right now are going, why didn't I do it that way? I was a lot faster than what I did. Right? I saw a lot of you multiply here, top and bottom by radical 6. I saw some of you do a factor tree on the 40, which would have given you, what, 2 radical 10 over radical 6. And then I saw you guys multiply by radical 6. So you had 2 radical 60 over 6. Some of you stopped there. I can do factor tree here. So then I got a pair of 2's, which come out, makes that 4 radical 15 over 6. Then both of those can be divided by 2 to get me down here. So there's a lot of ways you can still get to the final answer, even if you didn't do it the way I did. I'm just lazy, and if I can do it in as few steps as possible and then keep my numbers as small as possible, that's what I'm going to do. Okay, so simplify that fraction first. I turned 40 over 60 into 20 over 3. Use your radical, which was step 2. Use my radical on that 20, pulled out any pairs I had. Then I rationalized, and then there was nothing left to simplify. Question? Yes. What does a pair of 2's come out as? Just a 2. Yeah, not a 4. All right. Did anyone take my original path, 20 over 3, and then go from there? Aw, that's sad, guys. Simplify first, right? Isn't that how I started today? I told you, most people won't simplify or divide first. For whatever reason, you get all excited because there's a radical on the bottom, and you just kind of, you've got to rationalize. Like, you just can't help yourself. I've seen people rationalize first, and the problem gets, like, huge by the time they're done. Whereas if they just simplified from the start, it divided. It was like 30, radical 30 over radical 3. 30 over 3 is 10, right? I mean, just so I can show you, because I know this happens. If I had like radical 30 over radical 3. Okay, so think through this. Let's say I just went ahead and rationalized first. right? So I multiply top and bottom by radical 3, give me radical 90 over 3. Then I'd have to do a factor tree. So I'd be like, all right, I got a pair of 3's, left over 10 over 3. Then I have to simplify, so my answer is just radical 10. I can get there. Or I can go, look, that simplifies to radical 10. Yeah, I'm done. What would you rather do? One step. Done. Okay, simplify first. I'm trying to save you guys time and a whole lot of chances to make an easy mistake. Okay, simplify first. Questions? Anything at all? Are you going to remember to simplify first? You won't. Try to remember to simplify first, okay? Look how much faster this problem was. Isn't that great? That is one step, or all of that. Okay, simplify first.